Hello, in this video we are going to discuss the basic theorems of vector geometry. And dear friends, welcome to Now Maths is Easy with Ram sir. And now in this video we are going to discuss the first three theorems of vector geometry of class 10 optional mathematics. Now let's see the first theorem. That the theorem 1 goes like this: if OA and OB be the position vectors of the point A and B with respect to the origin O respectively, then vector AB is equal to vector OB minus vector OA. So here let's see that the question has given the position vector of the point A and the point B, okay, is vector OA and vector OB, right? Now we have to prove that this vector AB, will be the vector OB minus OA. Great. Now let's see, given that vector, we can see that here we can see triangle, in triangle AOB, okay? In this triangle AOB, we can say that vector OA plus vector AB is equal to vector OB. Okay, so this is by triangle law of vector addition. This is by the triangle law of vector addition. And from here, I can say that vector AB is equal to vector OB minus vector OA. It is now proved. It was so easy. Now let's check the second theorem. Here we go with the second theorem of the vector geometry. So the second theorem goes like this: that if vector A be the position vector of the point A, vector B be the position vector of point B, and if the point B divides AB in the ratio m:n, then prove that position vector of P is vector OP equal to n times vector A plus m times vector B upon m plus n. Okay, so what we are given, first of all, let's check. Okay, so here are the position vector. So let's take origin O here, and I have point A. Similarly, I have another point B. Great. Now I have the position vector A is vector A, and position vector of B is vector B. That's given. And here in between AB there is a point, okay? In between A and B there is a point P which divides AB in the ratio m:n. That means AP is m, okay, and this PB, its ratio is n. Okay, now we have to prove that the position vector of P, that means vector OP is n times vector A plus m times vector B divided by m plus n. Okay, now let's see the solution. Okay, given vector OA is vector A, vector OB is vector B, and also given that AP is to PB equal to m is to n. This is given. Okay, so now let's see that vector. So we can say vector AP is to vector PB is also m is to n, right? Or vector AP upon vector PB is equal to m upon n, right? Then we can say by cross multiplication we have n times vector AP equal to m times vector PB. Okay, so now what is vector AP? Let's check. So vector AP here, we can say that vector AP is vector OP minus vector OA. Okay, so it is n times vector OP minus vector OA equal to m times, what is vector PB? Vector PB is OB minus OP. Okay friends, how to write the vector in form of differences of two vectors. Now let's check our first theorem once more. Here you can check that vector AB is vector OB minus vector OA. Note it down that vector AB terminal point is B. So take the vector of terminal point minus the vector of initial point. Always keep in mind vector AB, B is the terminal point. So the vector of terminal point minus vector of initial point. Okay, so that we have done there. You can check its validity. Let's go to our theorem 2. So now here I have n times OP vector minus n times OA vector equal to m times OB vector minus m times OP vector. So let me bring OP to the same side. N times vector OP plus m times vector OP equal to m times vector OB plus n times vector OP. Okay, sorry, this is not OP but this OA. Great. Now I can take vector OP common from here and I get m plus n equal to, here I get m times vector OB. Vector OB is small vector b. So I write small vector b plus n times OA is vector small a. Okay. So finally I'm going to write vector OP is equal to n times vector a plus m times vector b upon this m plus n, which we had to prove, and this is proved. You had to prove that n times vector a plus m times vector b upon m plus n. So we have done here. Now let's check the last and the third theorem of today's video, and the next we bring the rest two theorems in the next video. So now let's check the third theorem. So this is our theorem 3. If P divides AB externally in the ratio m is to n, then the position vector of P is OP vector equal to m times vector B minus n times vector A divided by m minus n. So first of all, let's check what is this. Okay, so wait, let me take origin here, O, and let me take a line segment here. Okay, and this line segment is P. Here we have A and here we have B. Since P is the external of AB, that's why P is here. Wait, now let me join P with the origin, A with the origin, and B with the origin. Okay, so now let me name vector OA as small a vector and OB as small b vector. Now I'm given that the AB is divided by okay, in this way, by this point. Okay, so first of all let me write that this PA is M, where this PB, okay, is N. So PA is to PB will be M is to N. Okay, so now let me check what happens here. So let's go on solving. Solution. Let's say that vector OA is equal to vector A, vector OB equal to vector B, and also we are given that PA is to PB equal to M is to N, and here we have PA upon PB is equal to M upon N, and now by cross multiply I have N times PA equal to M times PB. Okay, so PA and PB are in the same direction, so we can say therefore N times PA vector is equal to M times PB vector. Okay, so my PA vector, let's check and write as the differences of vectors PA. So the terminal point is A, vector OA minus vector OP. So I write N times vector OA minus vector OP equal to M times PB. It means the terminal point is B, OB minus OP. OB minus OP. And from here I get N times OA vector minus N times OP vector equal to M times OB vector minus M times OP vector. Or I have here, uh, I have minus m times OP vector becomes plus m times OP vector minus n times OP vector equal to m times OB vector, and this one minus n times OA vector. Or if I take OP vector common, then I get m minus n, where here I have m times OB vector is OB vector, here OB vector is vector B and OA vector is vector A. Okay, so m times vector B minus n times vector A, and finally I have vector OP is equal to m times vector B minus n times vector A upon m minus n, and also this is proved. We needed to prove the same things, m times vector B minus n times vector A upon m minus n, and this is proved. Friends, if you like my video, do not forget to subscribe to my channel and share the video. Thanks for watching till the end.